Welcome to this session on machine vision, SICK UK webinar. And we're here to show you how machine vision is advanced and making it more simple, more adaptable to today's challenging environments and industrial conditions to help solve problems that we've seen in the past and we're seeing obviously currently, and showing you that vision isn't the difficult art form, let's say, that perhaps it can be commonly perceived. Okay, so if we get started, I'll just tell you who I am. I'm Neil Sandu. I'm the product manager for vision and LiDAR and systems in SICK UK. Here's my details, which you'll get copies of after this session in the form of the PDF of these slides. Okay, I've been at SICK now for just over 15 years, and I've spent most of my time here in machine vision, and I've been working in machine vision before joining SICK. So, yeah, relatively good amount of experience and knowledge in this area. And for those of you who are maybe not fully aware of who we are, SICK as a sensor and automation company is a global company based in headquarters originally in Southwest Germany, and now you can see we have developed into a company employing more than 10,000 people globally. Over 10% of that, in fact, in R&D, and we have a number of patents because of our innovating nature and quite a lot of solutions. So yeah, we're pretty much out there in terms of offering our solutions globally and throughout a wide ranging technology portfolio. So today's agenda is quite simple, quite basic, because say we don't want to get too weighed down into too many technical details. The basics is just a refresher look at machine vision and its bit of background, and then looking at some simple tasks and looking at some more advanced solutions and where we can come in and assist you. If we take vision itself, machine vision is a automatic way to inspect, view manufactured products, objects using cameras. And the idea of using camera technology to create this inspecting environment and perhaps take the workload away from a lot of manual human inspection came about in the 50s. And pardon me, the nature of it is to help with that level of inspection where potentially human inspection may have certain downsides. We're all human. We're all able to miss things from time to time, lose concentration, etc., etc. Especially looking at fast-moving produced goods. So the idea from machine vision is to complement the inspections and help then increase production levels, yield, quality, and obviously either redeploy or reduce labor in certain areas. So the automatic inspections are achieved. And if we look at machine vision as a general guide, we simplify it to four tasks, if you like, or a four-step approach, which is taking a picture, analyzing that picture with software that traditionally nowadays does sit on board what we call a smart device or vision sensor. We then send that result out, be it is something good, is something bad, or is there something been measured, is it some data, and then action is taken, be it either data sent out for reporting processes or even alerts for reject mechanisms if it's a component that needs to be removed from the production process. And then we just go back to the start and wait for the next object or the next thing to be taken to start it all over again. So a practical example here is we have a manufactured component, in this case a brake pad, and we're going to take a picture. We then analyze that picture. In this case, we're looking at the edges of the and you can see there where the dark meets the light. It's a contrast based area, so we can measure that width. We measure it and we come up with a number, and then if that is within the specified guidelines given to the system, it makes a decision on good or bad. and then, if need be, that then converts to an output from the system that says, okay, fire a reject mechanism or actuator to get the object removed from the process. So that's effectively the simple way we can look at machine vision. And typically, all the applications that we view, nine times out of 10 fall into one of four categories. So be it positioning, looking for something, where it is, locating it accurately with coordinates to report to a robot, for example, for it to be picked up. Inspecting, so looking, as we've just seen there, with the brake pad, potentially with defects, to make sure things are being manufactured to the standard that's needed. Measurements, as you've just seen again with the brake pad, we can look at measuring dimensions on produced goods, produced objects, to make sure they're within the spec required. Or are we required to read something? Is it the barcode? Is it a data matrix code, as you see there? Or is it some printed text on packaging that could be needed to be verified? It says what it's supposed to say, and is it legible? So typically, these are the main application kinds of areas that we see with machine vision. And I must add, any combination of these tasks, vision systems, of even vision sensors, are not just single function sensors. They can cope with multiple tasks, any combination of these tasks, to make sure a solution is applied to all the requirements needed in that particular application. As you would expect with machine vision, we are involved in industries very wide ranging across the board, as you see there, from automotive through packaging, consumer goods, etc., etc. So yeah, we see vision applications in pretty much every industry you can think of. So the message is, of course, keep it simple, less is more. So we think about vision sensor. So think about a standard photoelectric sensor. Takes power. Most of the time it's emitting light, getting light back, and it's sensing a presence or something and giving you an answer. Well, typically a vision sensor is doing a very similar kind of job, just in a different kind of way. If we take one of our vision sensors, you see one there called the inspector. It's a small two-dimensional 2D imaging camera. So when we say 2D imaging, it means it takes a picture that's contrast-based, as we know and use, let's say, even with our smartphones. So it just takes a normal kind of picture. And then the onboard intelligence in that sensor, in that vision sensor, says, in this case, have I got some text that means I've printed my best before date, use by date, or lot number where it should be, or haven't I? Here in the example, you can see where it has been printed and where it hasn't been printed. That sensor can make that distinction and send out outputs accordingly. In the same way that we talked about with the brake pad example we saw at the start, with regards to measuring the width. But then we can now look at vision sensors in a different way. We have 3D vision sensors. Those sensors now not only are not using the contrast-based imaging system, but they're using a height-based imaging system. So they're profiling objects in 3 dimensions. So not only are you getting the X and Y measurements possible, but you're also getting the Z, the height measurement. What does that give us? So here's an example of a food-based product. That means that if we have height information, we can look at things like volume. We can look at total size and measuring the diameters in the X and Y, but also in that Z axis. Even in this example, counting, if need be, the number of seeds on that particular object. So you can get some very clever and complex inspections carried out in a very simple way with a vision sensor. Pardon me. And again, if we take that brake pad example, instead of just measuring the width, with height-based information, we can start to look at surface-based defects. And so that really then comes into its own in terms of where that height data is really, really valuable. And then, of course, we've got the height data and we've got the imaging data that we have. We can start to look at more advanced solutions, like guiding a robot to pick up a large component, or even sitting above a conveyor belt to pick up small items in a very fast-moving way. And of course, when you're looking at any kind of vision solution, you have to obviously, when you have your task, or you think you have an application that you need to look at all the required parameters, and then we can make sure that the choice of camera or vision sensor can be straightforward, and you get the best one to do the job. And obviously, we're here to help you prove feasibility and capabilities on that. So let's look at the tools in a bit more detail. These are all sitting on board our vision sensors, and we talked about the positioning, inspection, measurement and reading aspects as the four main categories of vision solutions. So let's take three of those in terms of the positioning, the inspection and the measurements. And if we think about it from a 2D sort of contrast-based image to start with, we see that inspection tools can can provide great value on, in this case, verifying component shapes for correct assembly. Here you see that if you've got a part that's been pressed or manufactured, making sure that that part has been made to the right level is an ideal way for some kind of shape matching tools to really come into their own. As well as that, we talked about the print inspection before. Here you see an example again of looking at making sure that there's enough printed ink here to make sure that we know that that information has been printed correctly, even to the extent of training in a potential pattern based on you see there on a number on this little chip on a printed circuit board to make sure that the right one is actually placed rather than the wrong one. And that's all done by simple inspection tools, which then transforms across to looking at logos and labels and making sure that the right one is positioned on packaging or a bottle, and it's positioned correctly. And talking of position now, with regards to position tools, then not only, let's say, the aforementioned component is being manufactured correctly, we can actually look at position and making sure that it's in the right location if it's part of an assembly, or if it's in another kind of application where you're looking at free-formed objects, could be food, could be anything really, that we can track them, we can see them, we can count them if need be, and we can report their positions that could be valuable to any kind of guidance system, maybe involving a robot for picking and placing. And speaking of robot guidance and picking and placing, we can even use position tools to check that any kind of clearance is present if we're going to have, or it's needed before the robot makes its pick. And that's really where these position tools, again, can really help us. And finally, on position tools, we look at line guidance. So a lot of automated vehicles now operate in plants, and some of them follow this line guidance methodology, where the vehicle tracks a line on the floor and follows that to create its path. Now, the position tools in vision sensors can be used to track that line, make sure that that line is in the right position, or if it's moving, report that position out to the controller of that vehicle to make sure its navigation is completed correctly. And with measurement tools, we can see that they can help a vision sensor perform quality inspection tasks when manufacturing, again, components, making sure in this case holes are perhaps produced and pressed in the right areas, they're the right size, the right distance away from certain edges. So that's all part of measurement tools. Here you're measuring the widths and lengths of components, as well as circular tools and angular tools to make sure that things are manufactured at the right degree. If we talk about these same tools, inspection, positioning and measurement, from a three-dimensional point of view, we can see there that where the height data, we talked about height data with 3D, we can see where it really comes into its own in terms of in this case, looking at some bottles, but not only are we counting the bottles, maybe we're looking at the lid, the cap presence on it, but also because we've got the height data, we can even go down to the detail of checking that it's been screwed on to the right level. And that's again vital in this kind of application. And the other example here may be confectionery that you see on the screen, but this could be any kind of box or container that we can check inside to see what's inside, if it's empty, if it's not empty, if it's got a number of components within or objects within, is it the right number, are they the right way around, are they correct height? So it's all about looking at content verification in this case. Positioning wise, we can look at objects or large or small to see if they're present, to see if they're positioned correctly, if it's going to be automated for packing, if it needs to be rotated, if the whatever needs to change its orientation, we can look at that and we can report that out, as well as looking at this in a slightly different way in terms of bottles and making sure their orientation is aligned correctly. Let's say if they're going to be wrapped by a freeform or a flow wrapper, then you can make sure that if there is one not, let's say, aligned correctly as they should be, then we can find this out information and maybe to reduce incorrect packaging and downtime. And if we look at measurement tools with 3D vision sensors, we can see that height data really comes into its own again when looking to see if a measurement of in this case, a meat-based item is below the surface of the tray that it's been placed in, to make sure when the sealing comes about, it's going to seal correctly and not cause potential issues there. So by measuring the height and measuring the volume, we can make sure the right amount and the right level is catered for, and that also then transforms to another consumer style product here, this cream, where making sure by placing regions above and below where the level is supposed to be and measuring that level, we can make sure that the fill levels are all correct. So we're talking about these tools. We talk about setup of a simple system, and here you see one of our vision sensors, just inbuilt lens, inbuilt lighting to make sure that everything's as compact as possible. The right lens and the right lights to make sure that you're getting the best image possible to see the best detail that you need. And then the simple way to set these up is a simple configuration via some software, or even more recently now we kind of tend to shy away from specific software and use web browsers, because everything can be done via simple web browser based graphical user interface. So that's a very simple connection for configuration, and then that connection to the browser or PC software does not need to be there. You can remove that connection and the software all sits on board after it's been configured on board the device. And then all you need is the power supply, like a regular sensor, for it to power it, for it to do its job, and it will then therefore operate how it's been set up. Pardon me, and it'll report back its data or send out its outputs accordingly. And we talk about the graphical user interface, or GUI, then here you see an example how easy it can be. It's simply the image on the screen that's been captured, a little toolbox at the bottom where you just drag the tools that you want onto the screen, and you can position them to measure, in this case, the width of the component, and that's as simple as it gets. And that's, as I said, we don't try to things. It's there to be made easy to use, easy to deploy, and easy to install. So if we take a typical system setup, if we have a belt or conveyor producing with, in this case we have an actuator or reject arm that's available to us, then we can start with the camera with its inbuilt lighting and lens. We may need more than likely a trigger to say make sure that the camera receives a signal from a presence sensor to say there's something in front of me, take your picture, so we can inspect it and make sure we're taking a picture at the right time. We could directly also connect an encoder if that belt speed is quite changing speeds to a large degree. Then in terms of coping with taking the picture at the right time, or even sending an output to the reject arm at the right time, then the encoder input is very easy to use to make sure that that is repeatable, no matter what that speed of the belt is. And then if we're going to be sending out data, again, direct connection from this vision sensor straight to a PLC. So any data or images that are needed can be sent accordingly. And if need be, again, direct connection to a robot or a small screen, so the operations can be seen, or coordinates or information needed for the robot can be passed directly, all from the vision sensor, direct connection. And as simple as we can say it is, because it's typical of these system setup. Slightly more advanced applications. So we've looked at some relatively basic kinds of inspections and tools, and some of the more complex questions, let's say, we're getting asked nowadays in these times are: can we pick things up from moving belts at speed? Can we look at all the different kinds of information on the label in packaging? Can we direct automated vehicles to pick up dollies for transportation of many containers, as you see there, or pallets, or robot guidance on large components, inspection of electric pins, or even color-based inspections. So a lot of more advanced and complex questions are being asked, and we wanted to see if we could develop solutions that mean, yeah, we can solve these, let's say, more advanced tasks, but we don't need to make anything more complicated than we're talking about with so far with vision sensors. We're not saying it's a black art. It's not. It perhaps was commonly and even to this day still potentially perceived as a bit of a black art is machine vision, but we're trying to, break out of that mold in terms of it's simple, it's adaptable, and it's easy to get into. And the analogy I'm going to use is quite familiar, I would hope. We are looking at a smartphone. I think we all have them. We all have. Some of us have the same ones. Some of us don't. But we get what we want out of that phone by tailoring its functionality, and we tailor its functionality by downloading apps for looking at the weather, apps for reading the news, apps for go shopping, and these are all apps that we choose to download, and therefore forms the basis of what that phone does for us. So if we take that idea into the machine vision world, and instead of having lots and lots and lots of different hardware types, we can rationalize that down to a few, and therefore develop the software solutions based on an app style environment. Then it helps us in terms of producing less hardware, which is obviously helpful for us in terms of cost, but also in terms of being green. It also helps us in terms of development time, but also in terms of the people using vision systems, it means that they have less to worry about in terms of buying perhaps different kinds of cameras to solve different kinds of tasks, and potentially one camera could be bought to do one task in one particular situation, and further down the line, all that needed to be done is perhaps download some new software or an app like we do with our phones to change what we want to do. So that's the thought process behind it. So here we go. Here's the kind of the structure. It's develop an app, sensor app, and then the end user or customer will then, all they have to do is configure it and use it. They don't have to worry about any of the stuff behind the green arrow, and that's where we've come up with this of apps for the machine vision sensors, and the apps can be dropped on there, like a bit similar to what we do with our phones, and you can change the functionality of what we're doing. So SICK App Space, and SICK App Space is an environment that we've created like a programming studio that developers and internally within SICK, but also some of our partner companies around the world, and including a few in the UK, have been working with us to develop their own apps to solve their own tasks, and to great success. And we've developed a club where people can exchange ideas, and we hold conferences when we can. And so it's been a great success, and we're going to continue this app environment development for not just machine vision, but we're going into our LiDAR solutions and RFID solutions as well with an app style development structure. So it is something that we're going to see more and more of. So as a starting point from a machine vision point of view, we've come up with a few what we call initial solutions that are readily available right now, and these include, as you can see there, things like check labels, inspect connect pins, looking at color inspection, robot guidance, and even the palettes and dolly positioning. And we'll come on to those in a bit more detail later. In fact, we'll come on to them now. So we have the series of videos here that I'm just going to click on and run and just talk you through. They're not very long videos, so hopefully this won't take as long as you may think. So if we start off with picking. Belt picking, you see here our 3D vision sensor, our trispector, and you can see hopefully a laser line running across the object there, but also the blue belt. And so what it's doing, it's using that 3D laser triangulation method to produce the three-dimensional image to get that height data. We can have many different kinds of recipes or jobs saved there to cope with different types of products. Here you see an object, a bag here that could be vary in height as well as shape, and these smaller food-based items also are varying slightly in height and could be incorrectly produced to be too thin there is the example. So what we can do there is report back the shape, the height of the object for a robot to make sure it picks to the right level and doesn't damage the object, but also by telling it to training it not to pick up on certain types of objects with certain heights. We're also doing quality inspection at the same time. So is that kind of robot guidance can also be done with a static 2D type system. Here you see one of our 2D cameras at the top there, and these systems again can be used for robot guidance to be trained to look for certain shapes, certain objects, even identification of the object. If a known range of objects is coming down, so we can identify them, for example, in this example, and put them with their right respective components to make sure that we are picking to the right degree and picking to the right areas. And that also is also shown here on this video, where we're looking at the same camera, okay, with the app, with what we call Plock, and it's then being trained to look for a certain type of part. It runs that particular job, so many jobs can be stored in the camera, and you can see there it's being tracking the item, reporting an accurate coordinate location, but also orientation. So it looks at the angular orientation as well as the X and Y, so it knows that it can play the objects down in the right position. Can the robot? It's calibrated as you see there. So anytime an object comes through, it's imaged, it's then reported coordinates of and the orientation is sent back to the robot so it can be picking correctly. We can then come on to what we talked about in terms of picking packaging labels. So here you see again, same camera, different app, label checker it's called, and you see there the inbuilt camera and lighting illuminating the inbuilt lens, inbuilt camera, and illumination. Here you see the label example being inspected for reading the printed text here. We're looking at the barcodes, be it 1D, be it 2D. We can look at the position of the label. We can look at the logo and make sure everything is correct on that particular label. Okay, we then can come on to our electrical connector system again, same camera, different app called Pin Inspector, and here you see it working in one of our factories, looking at the pins in our some of our other vision sensors. But here you see the graphical user interface that's being used, again run on a web browser, and it's very simple, just to drag and drop tools to place the inspection areas where they need to be, place the area of interest on the right location just by dragging and dropping, and then you will see as the inspector there takes the image, it then looks at the pin location, as you can see there, to report back the coordinates and to make sure they're in the right locations and there's no damage occurred. Move on to the final three, and that's, first of all, we'll start with one of our automated vehicle solutions, which is called the dolly positioning system. Here you see one of our 3D cameras in an automated guided vehicle, and it's mounted at one end. It's then approaching what we call this dolly, this shelves on wheels, and you can see the algorithm they're working to find out what position is best for the approach, what angle to come in to make sure when it does its job in attaching and then transporting, it's all done correctly within the right limits and is done so to avoid less accidents or damage and downtime. And here you see some of the 3D data that camera is generating to make sure that the algorithm inside is being run at optimum efficiency. It's being programmed initially just by using a web-based graphical user interface, and then after it's been completed, it just runs its system from the power of the vehicle. In the same respect, in these types of environments, and here you see the same camera, different app. This one's the pallet pocket, as we call it. Here you see on a forklift that's being manually driven, but nowadays we see a lot of forklifts that are automated. We can use the information from the camera either to guide the driver or to do it automatically. Here you see the algorithm working to pick the pockets and the data to show that we can detect the distance and the position of the areas to make sure that the pallet is transported safely again without causing damage and perhaps unnecessary time that could be lost with any sort of accidents. And then finally, we'll look at our color inspection system. And our color inspection system is based on our small streaming camera and one of our new integration machines, which hosts the app that we're talking about, this color app. So the image is taken from the camera into the app on the controller, and you very simply, again, in a web-based graphical user interface, you set your color you're looking to try and sort or inspect for, and you can train it by the color palette there, or just by taking a live picture, and here you see being used in terms of to detect the right colors in the right items being produced and coming down the conveyor line. So that is a number of our app-based solutions that have been created in this new environment, but to reiterate, all to work on what we call vision sensors. So again, it's still a vision sensor. Everything sits on board. It just needs power once it's been configured. And hopefully you've seen there, they're quite easy to set up and run. And you don't need to be any sort of expert programmer to use them or even to get the most out of them. So that's the angle that we're coming from with our machine vision portfolio, if you like. We are looking to make machine vision more accessible for everybody, to make sure that everybody can easily get on board and get up and running, to make sure they can solve their perhaps tasks and issues with a high level of confidence, high level of robustness and repeatability. Included in the information that you receive is some links to some of the videos that you've just been seeing, but also to our website in terms of looking at our machine vision portfolio. And yeah, we'll happily talk to you and look at any sort of solutions that will be viable to help you solve your tasks and applications, should you think that machine vision is a worthy partner in doing so. Much. I'll now stop the recording and we'll take a few questions that have appeared on the chat or via speaking. Thanks again. Yeah, thank you.